What if I ask you, what is this? You would probably tell me that this is just a nasal spray for the common cold. Imagine your surprise if the answer was in fact the miraculous future treatment against Alzheimer's disease. Do you think I'm losing my mind? Watch this video before. You got it! The theme of the day is Alzheimer's disease. Become so widespread that I don't need to present it to you. But you should know that whatever we say today could also work for other neurodegenerative diseases, like Parkinson. Well, firstly, let me introduce myself. It will be quick, I promise you. Here, this is me in my office. My husband and my son name me the lab rat. And I hope this is not because I look like a mouse, but rather because I'm passionate about my studies. Indeed, I'm an M1 student in Master of Neurobiology. In this video, I will present a study made by a French scientific team from Aix-Marseille University, led by the professors Noirayahi and Jacques Fantini. They believe they have found the only possible universal treatment for Alzheimer's and Parkinson diseases. Here is the scientific article that we will present today. In our video, we will name this team the Donuts team. Before we get carried away, let's take a look back at the past. It was in 1907 that an incredible scientist named Alois Alzheimer discovered Alzheimer's disease. By performing an autopsy on the brain of his symptomatic patient, he discovered the presence of what we now call amyloid plaques and neurofibrillary tangles. Naturally, these two particular characteristics have led the scientific world to blame them for the disease. So we studied them for years. Just right now, I will give you the key to understand and create your own opinion. What we currently know is that amyloid plaques are created by an accumulation of abnormally thin chunks of amyloid protein called peptides. This protein, found in the space between neurons, is supposed to degrade naturally in its environment. But some too-thick forms of this protein can no longer be degraded, and thus aggregate and form plaques. Neurofibrillary tangles represent a destabilization of internal structures of the neuron that induces neuron death. On the other hand, calcium is suspected to have a key role. When there is an excess of calcium entering inside the neuron, it causes a whole cascade of reactions. The structure of many neuronal proteins changes and destabilizes the internal structure of the neuron as well as the nervous connections. This mechanism is a key that can explain neurons' death. But what remains unknown to this day is how all of this can set up. For decades, therapeutic trials have been based on symptomatic treatment of the disease and the destruction of amyloid plaques. Unfortunately, you know as well as I do that today this disease continues to impact the lives of more and more people. Faced with this situation, the Donuts team and other scientists around the world highlighted several elements that call into question our previous vision of this pathology. The first one is that we discovered the presence of these plaques in many healthy subjects. Secondarily, many therapies tested attacking these plaques had to be stopped prematurely due to dramatic effects. Thirdly, despite decades of research targeting aggregates, we still don't understand the mechanisms involved and what is the source of the disease. And the most important for them is that studies that we don't yet talk about enough highlighted the neurotoxicity of a smaller, isolated, and free form of amyloid proteins, which is named an oligomer. For Alzheimer, we are mainly talking about the oligomer beta-142. So what if we change our medical perspective about Alzheimer's disease by changing the culprit? This is what the Donuts team believes in. They think that we should see Alzheimer's disease as a membrane pathology, involving the binding of these oligomers with membrane lipids. This binding would induce a change in the shape of these oligomers, allowing them to enter the membrane. When a certain number of oligomers do it, they assemble themselves in the form of a donut in the membrane. This is named an amyloid pore. This hole imposed in the membrane of the neuron allows a massive entry of calcium inside the cell and then induces the chemical cascade of which we spoke earlier. To confirm this theory, Donuts team carried out several experiments. Firstly, they wanted to know if the presence of amyloid oligomers near a neuron can induce a massive entry of calcium inside the cell. If this turns out to be positive, it would mean that it's bound to the membrane and form the pore. Secondly, if the first experiment turns out to be conclusive, the Donuts team want to find out how oligomers can bind to the cell membrane. For doing this, they have to consider the membrane as a boat of fat. In scientific terms, we call it a lipid raft. And they want to find out what type of lipid the oligomers bind to. After having determined which lipid could be involved, the team have to prove that no pores can be formed if this lipid is absent on the membrane. In the hope of therapeutic application and using an artificial peptide that they will have created according to their results, they want to know if an attempt to block this binding would also block the cascade reactions. If this last step works, this artificial peptide could then be a key for further treatment. I'm very happy to tell you that all results were an awesome success. In fact, thanks to a fluorescence microscope, the team was able to demonstrate a massive entry of calcium during the first experiment, confirming the formation of an amyloid pore, the famous donut. Using the long-weave film balance technology with reconstituted lipid and the Hyperchem program, they found that oligomers binding to what we call a ganglioside lipid on the neuron membrane. In addition, the team succeeded in finding a universal code carried by the amyloid oligomers, but also others, such as Parkinson oligomers and other mutants involved in this type of binding. The absence of these gangliosides on the membrane blocked the pore creation, thus confirming that the formation of amyloid pores is dependent of these lipids. And the best for the end. Thanks to the universal code found, they were able to create a harmless molecule called MEP53, which can bind to gangliosides by competition with the amyloid oligomers. This peptide blocks the binding of the oligomers to the membrane and then induces the neuron's survival. Since the publication of this study, this team has been trying to be heard by the scientific world. The artificial peptide has been successfully tested on several animal models. The team is currently developing a preventive and curative treatment in the form of a nasal spray. In 2021, they plan to start clinical trials on humans. Hope this will be a success. To finish with a little humor, I have only one thing to say. Decidedly, donuts are not so good for health. If you like this video, feel free to share it and to give a thumbs up. In doing this, you can help the Donuts team to promote their discovery. You will also help me to know if this type of video interests you, in order to, perhaps, make you discover other scientific work soon. Ciao!